Our solar system isn't isolated. Interstellar objects ejected from distant planetary systems occasionally pass through our cosmic neighborhood. These mysterious travelers, forged in the chaos of alien worlds, drift for millions of years before crossing paths with our sun. For most of human history, their existence was only a matter of speculation, a tantalizing possibility that fueled the imagination of astronomers and dreamers alike. For centuries, these visitors were only theoretical, until 2017, when Oumuamua was discovered, confirming their existence. Its detection was a watershed moment, sparking excitement and debate across the globe. Suddenly, the idea that objects from other star systems could reach us was no longer science fiction. It was reality. Each new detection is a rare opportunity. These objects are time capsules, carrying secrets from other star systems. They offer a direct glimpse into the chemistry and history of distant worlds, preserved in their icy cores and rocky surfaces. By studying them, we can piece together the story of how planets and solar systems form and evolve. The second visitor, 2I Borisov, resembled our own comets, but Oumuamua's strangeness left us eager for more. Borisov's familiar tail and composition hinted at common processes across the galaxy, while Oumuamua's odd shape and motion challenged our understanding, raising new questions about what else might be out there. The scientific community races to study each fleeting visitor before it vanishes into the void. With only days or weeks to gather data, astronomers coordinate globally, using every available telescope to capture images, spectra, and trajectories. The pressure is immense, but so is the potential for discovery. Every object is a potential game-changer, possibly rewriting our understanding of planetary formation and our place in the cosmos. These interstellar messengers could hold clues to the origins of water, organic molecules, or even the building blocks of life itself. Each one challenges us to look deeper and think bigger. Atlas, a vigilant sky survey, scans for these cosmic travelers, and with each year, our chances of finding another increase. New technology and global collaboration mean we're more prepared than ever to spot the next interstellar visitor, no matter how faint or fast it may be. When the third interstellar object, 3I, was detected, anticipation was high. Scientists and enthusiasts alike waited eagerly, wondering what secrets this new arrival might hold, and how it would compare to its predecessors. No one was prepared for what 3I Atlas would reveal. Its discovery marked not just another chapter, but the dawn of a new era, one where the universe feels a little closer, and the mysteries of the stars are within our reach. The discovery of 3I Atlas began quietly, almost unnoticeably, just a faint, unremarkable dot on a hyperbolic path, flagged by the tireless eyes of automated sky surveys. To the untrained eye, it was nothing more than a speck among countless others, drifting through the vastness of space. But to astronomers, every new object is a potential mystery, and this one was no different at first. Within hours, astronomers around the world turned their instruments toward the newcomer, eager to study its composition, trajectory, and motion. Teams worked late into the night, gathering as much data as possible, hoping to catch a glimpse of something unusual. Initial data suggested it was just another comet or asteroid, an icy wanderer or rocky fragment passing through our solar system like so many before. But then, something extraordinary happened. A faint, rhythmic pulse of light was detected, repeating with uncanny precision, as if the object itself was sending out a message across the void. At first, the signal was dismissed as a technical glitch or interference. Yet, as more data poured in, the pattern persisted and became even clearer, defying easy explanation. The signal was soon flagged as extraordinary, structured, artificial, and unlike any natural phenomenon ever recorded. Its regularity and precision set it apart from the random noise of the cosmos. News of the anomaly spread rapidly among astronomers and researchers, sparking excitement, debate, and a flurry of speculation about its origin. The pulses were too stable, too precise to be random or natural. No known comet, asteroid, or star could produce such a signal. The object was still far from the sun, ruling out typical comet activity like outgassing or solar heating. Its behavior remained a puzzle. We had found our third interstellar visitor, and this time, it was blinking at us, as if inviting us to unravel its secrets. When we look up at the cosmos, the light we see is wild and unpredictable, Stars twinkle because their light passes through our turbulent atmosphere, comets glow as sunlight excites their icy tails, and asteroids reflect sunlight in uneven, shifting patterns. Even the most beautiful cosmic displays, like auroras or meteor showers, are governed by chaotic, natural forces. There's a randomness to it all, a lack of perfect order. But then, 3I Atlas appeared, and its light pulses broke the mold. These flashes weren't random or messy. Instead, they were mathematically precise, repeating at exact intervals that matched orbital harmonics, like a cosmic metronome keeping flawless time. What made this even stranger was the object's distance from the sun. It was far too remote for solar-driven activity to explain the regular flashes. The energy had to come from within, not from any external source. As scientists dug deeper into the data, they uncovered even more complexity. The light wasn't just a single repeating flash. There were layers, primary, powerful bursts, and beneath them, subtler, secondary flickers, each following its own distinct rhythm. These overlapping rhythms hinted at multiple mechanisms working in perfect coordination, as if several systems were engineered to operate together. In nature, such precision and complexity rarely coexist, but in technology, it's a hallmark: multiple components, each with a role, synchronized for a purpose. The evidence was mounting. Precision timing, internal power, and intricate layered signals all pointed in one direction. We realized we weren't observing a natural phenomenon at all. Instead, the light was a techno-signature, evidence of technology, not nature, reaching across the void. 3I Atlas was broadcasting its presence, sending out deliberate structured flashes for anyone watching to see. Suddenly the question changed. Why was this object built, and what message was it trying to send across the stars? Because in all our experience, nature simply doesn't flash like this. Only intelligence leaves such a signature. Extraordinary claims demand extraordinary evidence, and the artificial lights from 3I Atlas required rigorous verification. NASA and other agencies focused their most powerful instruments on the object. After weeks of observation, NASA confirmed the artificial signals, repeatable, real, and independently verified. Every alternative explanation was systematically ruled out. Atmospheric illusions, satellite reflections, cosmic rays, none fit. The light was intrinsic to 3I Atlas. The confirmation sent shockwaves through science and the public. This was no longer an astronomical curiosity. It was a global event. Humanity was now staring at technology from another star system. The evidence was undeniable. With its artificial nature confirmed, scientists scrutinized every aspect of 3I Atlas and found more mysteries. Its trajectory showed tiny, discrete course corrections, hinting at micropropulsion and self-guidance. The object's rotation would stabilize in sync with changes in its light pulses, as if reorienting for a purpose. Thermal imaging revealed hotspots cycling in rhythm with the secondary light pulses, suggesting an internal energy source. 3I Atlas wasn't inert. It was active, generating and managing energy. High magnification images showed its surface was made of uniform, unusual alloys, with geometric patterns etched across it. These features hinted at deliberate, intelligent design. It didn't just act like a machine, it looked like one. Every detail reinforced its artificial origin. 3I Atlas wasn't following a simple program, it was reacting to its environment. As it moved through varying solar wind densities, its light pulses adapted in frequency and duration. This suggested active adjustment, possibly for shielding or environmental scanning. The pulses varied across wavelengths, sharp and ultraviolet, smooth and infrared, implying complex internal control. 3I Atlas manipulated its emissions, perhaps to serve multiple functions or broadcast different information. This adaptive, responsive behavior is a hallmark of advanced technology. The object was engaged in a silent dialogue with our solar system. We were witnessing a conversation that began light years away. With mounting evidence of artificial origin, scientists proposed several hypotheses about 3I Atlas. It could be an interstellar probe, like our Voyagers, sent to explore the galaxy. Its lights and behaviors might be diagnostic cycles or scanning mechanisms. Another theory: it's a derelict vessel or fragment, an ancient relic still executing its programming. Or perhaps it's observing us, making course corrections to study our solar system. Its communication is purely optical, a language of light we're only beginning to decipher. Whether probe, relic, or observer, 3I Atlas is tangible proof we're not alone in building star-crossing machines. Its true purpose remains a mystery. The discovery of 3I Atlas has transformed the search for extraterrestrial life. SETI now looks for technosignatures, artificial lights, pollutants, waste heat, and physical artifacts. Multidisciplinary teams are decoding its signals, treating the flashes as a new language. Past interstellar visitors like Oumuamua are being re-examined for missed technosignatures. As 3I Atlas prepares to leave, we're left with profound questions and a clear mandate. We must develop better monitoring to find and study these objects sooner. The discovery is not an endpoint, but the dawn of a new era. We've found a message in a bottle. Now, our journey to understand its sender truly begins.